Hi students, welcome to my channel Crack Physics with Anisha. Let's make physics concepts simple, fun and clear. Next sub-question from the same figure-based question. A photographer is using a DSLR camera to take a picture of a flower. The flower is positioned 150 mm away from the camera lens. The actual height of the flower is 80 mm and the image height formed on the camera sensor is measured to be 20 mm. Calculate the focal length of the camera lens. What we have to find? We have to find the focal length of the camera lens. What all data are given? Flower is positioned at 150 mm away from the lens. That means flower is the object here. Basically, our object distance is given as 150 mm from the lens. Now, if it is object distance, definitely you will take it as negative because object is always kept towards the left of the optic center. Now the actual height of the flower is given. That means basically the object height HO is given as 80 millimeter. Again applying the sign convention, we know that height of the object is taken positive because object will be always kept above the principal axis and measurements above the principal axis is taken as positive. Yes. Now calculate the focal length. How we can find the focal length? Only using lens formula we can find the focal length. And according to that, we should know what V also 1 by F is equal to 1 by V minus 1 by U, where V is the image distance, but that is not given, right? That is not given. So we have to find the image distance. Now one more quantity is given. Yes, 20 millimeter. What is it? The image height formed on the camera lens HI is given as 20 millimeter. So applying the sign convention, we have seen that the image formed was real and inverted. If it is inverted image, we have to take height of the image as negative because we will take measurements to the below the principal axis. So as it is below the principal axis, the measurements below the principal axis is negative. We take it as negative. Now, how we will find the image distance? It is not given, no? But still, we can find the magnification using the formula HI and HO that is given. So, magnification is equal to HI by HO, right? That is also equal to V by U based on the object distance and image distance. Yes, we know what is HO, HI, V, not V, U, V. We have to find, substitute the values. So, HI, this can be written as HI by HO into U is equal to V, right? We can take U to LHS. So, V is equal to HI value. What is HI value? That is minus 20 divided by HO. HO is 80 millimeter into U. U value is minus 150 millimeter. We are not converting the units because all the units are in millimeters only. So no need of converting. Final answer you will get in millimeter. That's all. Yes. So when you solve it, you will be getting, yes, negative and negative will become positive. So it is 1 by 4 into 150. Yes, that is 150 by 4. This is our image height, that is 150 by 4 is 37.5 millimeter. Not image height, image distance. Yes, image distance is obtained as 37.5 millimeter, right? If you get the image distance, can't you find the focal length? Yes, 1 by F is equal to 1 by V minus 1 by U. Just now we found it is 37.5. So 1 by 37.5 minus 1 by U, that is 1 by minus 150. Now negative and negative will become positive. So it is 1 by 37.5 plus 1 by 150. Either you can take the LCM or you can cross multiply. Anyways, you will be getting 5 by 150 as the 1 by F answer. Now you take the reciprocal because 1 by F is 5 by 150, right? So you have to take the reciprocal. So F is equal to 150 by 5 and that is equal to, yes, it is 30 millimeter. So focal length is obtained as 30 millimeter. Simple calculation only. If you just substitute the given data in the non-formulas, you will get the answer. So this is the final answer. Focal length is 30 millimeter. Moving to the next question. Zarina worked as an apprentice in a factory where flashlights and solar cookers are made. She learned to make the circuits, the design of the light box and light concentrators for the solar cookers as well. She learned the uses of lenses in making all those tools. Based on your understanding of lenses, answer the following questions. A. What kind of lenses are used in flashlight and light concentrator of the solar cooker? Give reason for your choices in part A. So both the answers we can do together. So first part, we have to say which type of lens is used in flashlight and light concentrator in solar cookers. So first we'll discuss about flashlight. We'll discuss the reason also why we are choosing that particular lens. We will be choosing a concave lens for flashlight. Now the reason is concave lens is also called as a diverging lens, right? That means it can diverge out the light rays. So flashlight is a device which is used for searching. Okay, if we have to find something, if we have to see something in dark, we'll use a flashlight. Okay, so we have to get a wider view of the surroundings with this light. And that is possible only if we use a concave lens. So when we use a concave lens, it diverges out the light rays. You know that when the light rays are coming from any source, okay, we can consider like a parallel ray it is coming. After refraction, it diverges out the light rays, isn't it? So we will be getting a wider view of the surrounding. But if we are using a convex lens instead, what happens? It will converge the light rays, isn't it? It will converge the light rays, and this wider view of the surroundings is not possible when we use a convex lens. That's why we use a concave lens for flashlights. Yes, it is better for searching. Next case, when we are using the light concentrators in solar cookers. Now, what is a solar cooker? It is working based on solar energy. Using sunlight only it works, isn't it? That means using sunlight, we can increase the temperature of the cooker and cook the food, right? So there we'll be using a convex lens. The reason for using convex lens is that it is called as a converging lens because it converges the light rays to a particular point, right? So when we consider the solar energy, that means basically our sunlight coming from infinity, this convex lens will, yes, converges these infinite number of light rays from the sun at a particular point, which is the focus of the convex lens. And at this focus, what happens due to this high intensity number of incident rays focusing on that particular point, the temperature of that point will rise. Due to the increase in temperature, more heat energy will be produced and it will be easy to cook the food, right? Yes. For that reason, we are using convex lens in solar cookers as light concentrators. That's the answer. The remaining part of the questions are given here. C part and D part, we'll solve it together. So section C question is, an object is placed 40 centimeter away from a lens which is normally used in solar cooker. The image formed is twice the size of the object. Calculate the focal length of the lens. So we have to find, section C we'll be doing focal length of the lens used in a solar cooker. We know that we'll use a convex lens there. So we have to get the focal length positive. Yes, positive focal length. So we'll start. It is given the object is placed 40 centimeter away from the lens. That means the object distance is given 40 centimeter. As this is object distance, you have to take negative. As usual, you know it is kept to the left of the optic center. Now the image formed is twice the size of the object. So size of image is given, but twice the size of the object. Now size of the image is expressed using the height of the image hi, that is given as twice the height of the object. We have to find the focal length. As done before, we know if height is given for image and the object, we can find the magnification hi by ho, right? That is given as 2. The magnification is given as 2. Now, to find focal length, you have to use lens formula in which 1 by v minus 1 by u, v is not given in the question. So next, we are going to find the value of v using the formula of magnification in terms of image distance to object distance. We can say that object distance is given, magnification is given, image distance. V is equal to m into u. Yes, it is m into u. Now, substituting the values, v is equal to m, magnification is 2 and u is minus 40. Now remember, when we are doing this problem, we have to apply the sign convention. Yes, we have to apply the sign convention. So here, the object distance sign convention we have given already, that is minus 40. What about its magnification? We know that it is an enlarged image. It is twice the size of the object. So it is an enlarged image. But we were not aware whether it is a real or inverted image or virtual and erect enlarged image. There are two possible enlarged images for convex lens. Real enlarged image and virtual enlarged image. And we know that in this case, the convex lens is focusing the light rays coming from sun. That means from infinity, because this is a solar cooker. So this light rays coming from the sun will be focused at the F2 focal point on the opposite side of the object. F2 it will be focusing. So towards the optic center, towards the right of the optic center is our focal length. Got it? Yes. So this image distance, and we know that this image distance will be positive, but yes, image distance will be positive, but as it is real and inverted image will be giving, because this is a real image, so it will be inverted. If it is an inverted image, the height of the image will be negative, right? Height of the image will be negative. So basically, if it is a real image, its magnification will be minus 2. Height of the image will be negative. That's why the magnification will be minus 2. Height of the object is always positive. But as it is a real image, height of the image is negative. So magnification is minus 2. So you have to apply that sign convention also here. See, so we get V is equal to M into U, that is minus 2 into minus 40. So 2 into 40, minus and minus becomes positive. So 2 into 40, that is equal to 80 centimeters, right? Yes, centimeters. See, we got the image distance also as positive. Now it is correct, isn't it? Once you get the image distance, you can find the focal length. 1 by F is equal to 1 by V minus 1 by U. That is equal to 1 by 80 minus 1 by minus 40. Minus and minus becomes plus. So 1 by 80 plus 1 by 40. Take the LCM. You will be getting 3 by 80, right? 3 by 80. Multiplying here numerator and denominator with 2. So we get 3 by 80. So 1 by F is 3 by 80. So what will be F? F will be equal to 80 by 3. Yes, 80 by 3, that is equal to 26.67 centimeter. This is the final answer to find the focal length of the given lens in solar cookers. Next, we can discuss the D part of the question. An object is placed 20 centimeter in front of a lens which is used in a flashlight, and the image is formed 10 centimeter away from the lens on the same side as the object. Calculate the focal length of the lens. So this is a flashlight, so we'll be using a concave lens. So we have to get the focal length in negative sign, right? Yes. So the object distance is given as u equals minus 20 centimeter, as we know. Yes, because U is towards the left. Now image is formed. V is given 10 centimeter away from the lens on the same side of the object. So V is also negative. So it is also taken towards the left of the optic center, because this is a virtual image, virtual and direct image. We have to calculate the focal length. Simply apply the lens formula. 1 by F is equal to 1 by V minus 1 by U. That is equal to 1 by minus 10 minus 1 by minus 20. That is equal to minus 1 by 10 minus minus, that is plus 1 by 20. Either you can take the LCM or cross multiply. So if you cross multiply, you will be getting minus 20 plus 10 by 10 into 20. That is equal to minus, yes, it is minus 10 by 200, that is equal to minus 1 by 20. So 1 by f is equal to minus 1 by 20. So what will be f? F is equal to minus 20 by 1 or minus 20 centimeter. Directly we got the answer. See, focal length is negative because it is a concave lens. That is the final answer. In this question, a circuit diagram is given. The arrangement of resistors shown in the above figure is connected to a battery. The power dissipation in the 100 omega resistor is given as 81 watt. Calculate the current in the circuit, the reading in the voltmeter V2 and the reading in the voltmeter V1. So here the input voltage is not given. If the input voltage was given, it was easy to find the voltage across V1 because it gives the input voltage across the cell or the battery, right? Yes. So that is not given, but we are provided with the resistors 100 omega resistor which is in series connection and two 25 omega resistors which are connected parallel to each other, and together these 25 omega resistors are in series with the 100 omega resistor, and V2 is a voltmeter which is connected across this parallel combination of 25 omega resistors which give the potential difference across this parallel connection of 25 omega resistor. So first of all, they have given the power dissipation in the 100 omega resistor, that is given as 81 watt. Yes. Now the first question is to find the current in circuit, current represented by I in the given circuit. So if we have to find the current in the circuit, that means the total current flowing in the circuit, we have to find the relation of I is equal to V by R, which is the Ohm's law, where V is the total voltage in the circuit and R is the total resistance, right? But here the total voltage is not given, but still we can find the total resistance in the circuit, right? Yes, because 100 ohm, 25 and 25 ohm is given, we can find it. So this relation is not applicable here because voltage is not given. So first of all, we can do one thing. We can find the total resistance anyhow. Because if the power is given and if we are provided with the total resistance, can't we find the total current? Definitely. How? Let's see that. So total resistance in the circuit RT, how we can find it? It is basically this 100 omega resistor R1, if we take it as R1, and these two 25 omega resistor together, its combination, if I am taking it as R2, the total resistance, they are in series. So R1 plus R2 I can take, right? But this R2 itself is a parallel combination. So first we have to find what is this R2. R2 is basically a parallel combination of what? These two 25 omega resistor. So I am going to find that R2 first. So if it is a parallel combination, use the formula 1 by Rp is equal to 1 by R1 plus 1 by R2. That is 1 by 25 plus 1 by 25. Yes, that is denominators are same. So 2 by 25. So what is R2? R2 is basically reciprocal of it. That is 25 by 2. That is equal to 12.5 omega. This is the net resistance or effective resistance of these two 25 omega resistor connected in parallel. So instead of that, we can simply put a single 12.5 omega that will also give the same result, same current reading. Yes. Now we can find the total resistance. The total resistance RT, how we can find it? It is, yes, R1 plus R2. R1 is 100 omega plus R2 is 12.5 omega. Just now we found it. That is 112.5 omega. This is the total resistance in the circuit. Yes. Okay. Now, if we are provided with, why we are finding this total resistance? Because we need that for the coming questions. Okay. If we are provided with the power of this 100 omega resistance, that is 81 watt, yes, and we are provided with the resistance that is 100 omega, yes, can't we find the current through the 100 omega resistor? The current through the 100 omega resistor is, I am writing it as 100, I100, that is the relation connecting power, resistance and current. What is it? P is equal to I square R, isn't it? So what is I square? I square is equal to P by R. So what is I? I we can write it as I is equal to under root P by R. P by R, that is equal to under root of 81 by 100. Yes. Now root 81, that is 9, and root 100, that is 10. So we get it as 9 by 10. That is I through the 100 omega resistor is 0.9 ampere. And we know this 100 omega resistor is in series in the circuit, series combination in circuit. So whatever current passes through this 100 omega resistor will be same as the total current passing through the circuit, right? So because the current starts from the positive terminal, yes, it passes through the 100 omega resistor, yes, it will split in this particular point, that is 25 omega. Yes, 25 omega, but it recombine here, and again the 0.9 ampere current will pass through the whole circuit. So whatever current passes through the 100 omega resistance is the total current passing through the circuit, because in series we know that the current will be same along all the circuit, isn't it? Current is same, only the potential difference is different. So we can say the total current in the circuit is 0.9 ampere. Now second part of the question, that was the first part. Now second part of the question is given by the reading in voltmeter V2. That means the voltage or potential difference across V2. We already know potential difference can be found using the relation V is equal to I into R. Here we are finding V2, so we have to find the total current passing through this branch 25 omega together, and R the total resistance there in the parallel combination, that is R2, right? I into R2. Now we know that the current passing through both the 25 omega together is 0.9 ampere, because this current will split at this particular junction, right? Yes, one second, I'll just show it. Yeah, the current will split at this particular junction once it reaches at this point, isn't it? 0.9 ampere current will split it. Yes, but still when it recombines here, again it becomes 0.9 ampere. So we have to find the voltage across these 2 points only. So total current passing through these two parallel combination is 0.9 ampere. The splitting thing, we don't want to know that. So anyways, voltage across these two resistors V2 is 0.9 ampere into the total resistance there, effective resistance there, as they are parallelly connected to each other. We know R2, we've already found the relation, that is 12.5 omega, the resistance, isn't it? So we get 0.9 into 12.5, that is 11.25 voltage. That is the potential difference across V2. Once you get the potential difference across V2, can't you find the potential difference across V1 also? Yes. How? V1 is basically the total potential difference supplied to the circuit. It is connected across a battery, right? So that will be equal to the total current passing through the circuit into the total resistance of the circuit. Now total current in the circuit, we already found it is 0.9 into the total resistance. We already found the value. The total resistance is 112.5. Substitute that value, 112.5, and that is equal to how much? 101.25 voltage. So this is the voltage in the voltmeter V1. Now in this question, this effective resistance, calculation of this effective resistance can be done in individual questions. So in the first question, you just need to find the current in the circuit. From here onwards, you can find the current in the given circuit. Using the power value and resistance value, you can find the current in 100 omega, and that will be the current in the given circuit. Then for second and third question, you have to find the effective resistances. That one you can follow using these steps given. So this is the final answer for this question. Thanks for watching. Subscribe for more videos, hit the bell icon and join our learning journey.